Hello guys and welcome back. Today we're going to talk about photo detectors, or commonly known as photo eyes or photo sensors. Photo detectors are widely used today in industrial, commercial, and basically most applications. They can be used to sense the presence or absence of almost any object. Photodetectors do not have to make physical contact with the object they are trying to sense. So there is no mechanical arm to wear or parts to wear out. Many photodetectors can operate at speeds that cannot be tolerated by mechanical contact switches. They are used in almost every type of industry, and their uses are increasing steadily almost every day. Types of detectors include photovoltaic, photoemissive, and photoconductive. The photovoltaic type devices are more often called solar cells. They are made of silicon and have the ability to produce a voltage in the presence of light. The amount of voltage produced by a cell is determined by the material it is made of. When silicon is used, the solar cell produces 0.5 volts, or half a volt, in the presence of direct sunlight. If there is a complete circuit connected to the cell, current will flow through the circuit. The amount of current produced by a solar cell is determined by the surface area of the cell. For instance, assume a solar cell has a surface square area of 1 square inch, and another cell has a surface square area of 4 square inches. If both cells are made of silicon, both will produce 0.5 volts, or half a volt, when in direct sunlight. The larger the cell, however, will produce 4 times as much current as the small one. The symbol we use today to represent a photocell is basically the battery symbol with an arrow pointing down towards the cell. What this symbol means is basically that the device has the ability to produce a voltage, and the arrow means that it must receive light to do so. Photovoltaic cells have the advantage of being able to operate electrical equipment without external power. Since silicon solar cells produce only 0.5 volts, or half a volt, it is often necessary to connect several of them together to obtain enough voltage and current to operate the desired device. For example, assume that a solar cell are to be used to operate a DC relay coil that requires 3 volts at 250 milliamps. Now, assume that solar cells to be used have the ability to produce 0.5 volts at 115 milliamps. If 6 solar cells are connected in series, they would produce 3 volts at 150 milliamps. The voltage produced by the connection is sufficient to operate the relay, but the current capacity is not. Therefore, 6 more solar cells must be connected in series. This connection is then connected parallel to the first connection producing a circuit that has a voltage rating of 3 volts and a current rating of 300 milliamps, which is sufficient to operate the relay coil. Photoemissive devices. Photoemissive devices emit electrons when in the presence of light. They include such devices as the phototransistor, photodiode, and the photo SCR. The emission of electrons is used to turn the solid-state components on. When the phototransistor is in darkness, no electrons are emitted by the base junction, and the transistor is turned off. When the phototransistor is in the presence of light, it turns on and allows current to flow through the relay coil. The diode connected in parallel to the relay coil is known as the kickback or freewheeling diode. Its main function is to prevent induced voltage spikes from occurring when the current suddenly stops flowing through the coil and the magnetic field collapses. The relay coil will turn on when the phototransistor is in the presence of light and turned off when the phototransistor is in the darkness. Some circuits might require the reverse operation. This can be accomplished by adding a resistor and a junction transistor to the circuit. In this type of circuit, the common junction transistor is used to control the current flow through the relay coil. For example, resistor R1 limits the current flow through the base of the junction transistor. When the phototransistor is in darkness, it has a very high resistance. This allows current to flow to the base of the junction transistor and turn it on. When the phototransistor is in the presence of light, it turns on and connects the base of the junction transistor to the negative side of the battery. This causes the junction transistor to turn off. The phototransistor in the circuit uses a stealer transistor. A stealer transistor steals the base current away from some other transistor to keep it turned off. Some circuits might require the phototransistor to have a higher gain than it has under normal conditions. This can be accomplished by using the phototransistor as the driver for a Darlington amplifier circuit. A Darlington amplifier circuit generally has a gain of over 10,000. Photodiodes and photo SCRs are used in circuits similar to those shown for the phototransistor. The photodiode will allow current to flow through it in the presence of light. The photo SCR has the same operational characteristics as the common junction SCR. The only difference is that light is used to trigger the gate when using the photo SCR. Regardless of the type of photoemissive device used or the type of circuit it is used in, the greatest advantage of the photoemissive device is speed. The photoemissive device can turn on and off in a few microseconds. Photovoltaic and photoconductive devices generally require several milliseconds to turn on or off. This makes the use of photoemissive devices imperative in high-speed switching circuits. Photoconductive devices. Photoconductive devices exhibit a change of resistance due to the presence or absence of light. The most common photoconductive device is the cadmium sulfide cell, or CAT cell for short. The CAT cell has a resistance of about 50 ohms in direct sunlight and several 100,000 ohms in darkness. It is generally used as a light-sensitive switch. When the CAT cell is in darkness, its resistance is high. This prevents the amount of current needed to turn the relay on from flowing through the circuit. When the CAT cell is in the presence of light, its resistance is low. The amount of current needed to operate the relay can now flow through the circuit. Although this circuit will work in the CAT cell, if the CAT cell is large enough to handle the current, it has a couple of problems. First, there is no way to adjust the sensitivity of the circuit. Photo-operated switches are generally located in many different areas of the plant. The surrounding light intensity can vary from one area to another. It is, therefore, necessary to be able to adjust the sensitivity for the amount of light needed to operate it. Second, the sense of operation of the circuit cannot be changed, but there might be conditions that will make it desirable to turn the relay on when the CAT cell is in the darkness. As I mentioned before, one of the advantages of photo detectors or photo eyes is that they do not require physical contact to either count or sense the presence of objects. And the other thing is they're very durable. So they're designed and manufactured to withstand different type of manufacturing, if you want to call it that. You know, we use them in CNC machines, conveyor belts, gates, industrial applications, refineries, chemical applications, safety curtains. A lot of people don't realize that robots, for example, have light curtains, and they use photo eyes to detect the presence of humans when the robots are working, and immediately shuts it off or sends an emergency signal to the control panel. So these sensors are very amazing. And the other thing is they can operate millions of times before they require any maintenance or repair at all. But most of the time we don't really repair these sensors. Once they die, we usually choose to replace them with the new ones. Okay guys, this is it for me today. Again, thank you so much for watching, and please like, share, and subscribe.